Hello everyone. In this video, I'm going to discuss that how do we evaluate indefinite integrals when we use the substitution method. So we are given this example that we have to find integral from 1 to 5 square integral of square root of 2x minus 1 dx. Alright, so let's first rewrite this as integral from 1 to 5 of 2x minus 1. The power of the function is half dx. So if we use our substitution method here, so we plug in that, so let u equals to 2x minus 1. So from here du over dx is 2, or du is equal to 2 times dx. But since when we replace in the integral, so we're going to replace in place of 2x minus 1, we write u raised to power half in place of dx. So we need the value of dx from here. So that would be du over 2. So in place of dx, we write du over 2. And one method is that you do not change the limits of integration, so you just keep your x limits from 1 to 5. So don't substitute this for u. So we have to first evaluate this integral and put that back in terms of x. So we have half integral of u raised to power half du, and limits we have for x only. So in this case, integral would be u raised to power 3 over 2. So increase the power by 1, divide by the same power, so half was already there, plus c. We don't need to do plus c because this is a definite integral. So, and the values of integration are from x equals to 1 to x equals to 5. And now we're gonna rewrite this as, so we notice that 2 and 2 gonna get cancelled, so we are left with 1 over 3 u raised to power 3 over 2, and the limits of integration are from 1 to 5. And then when we plug back the original variable, so we have in place of u 2x minus 1, which raised to power 3 over 2, and limits from x equals to 1 to 5. So now is a good time to use your limits because now we have everything in terms of x. So we get upper limit, so 5 times 2 is 10. So 2 times 5 minus 1 raised to power 3 over 2 minus 1/3 lower limit, so 2 times 1 minus 1 raised to power 3 over 2. So we get 1 over 3, 10 minus 1, which is 9 raised to power 3 over 2, minus 1 over 3, 1 raised to power 3 over 2. So when we do the calculations, we get 26 over 3 as our answer. So this is the value of our given definite integral. So that's one method when we don't change the values of the limits. We just keep that in terms of x only. So there is another way of doing this problem, which I'm going to discuss now. So we have the same problem. So first we do the substitution. So u is equal to 2x minus 1, du is equal to 2 dx, or dx is equal to du over 2. And we change our integral, so u raised to power half, and in place of dx we get du over 2. And now we also want to change the limits of integration so that we don't have to bother about x again and again. So we're going to calculate the new endpoint values for u. And how we're going to do that? So we notice that when x equals to 5, so what is the value of u? So u would be 2 times 5 minus 1, which is 9. Similarly, when x equals to 1, u is equal to 2 times 2 minus 1, which means, sorry, 2 times 1, because we have 1, right? So 2 minus 1, which is 1. So these are the new values for u. So we write the endpoint values, so from u from 1 to 9. And now we can just take our integral. So integral of u raised to power half would be u raised to power 3 over 2 divided by 3 over 2, and the values of the limits go from 1 to 9. So we get, so 2 and 2 cancels, 1 over 3 u raised to power 3 over 2. So limits from 1 to 9. So now you can simply plug in the values of u because the limits are in terms of u. So 9 raised to power 3 over 2 minus 1/3, 1 raised to power 3 over 2, which we solve. In the end, we get 26 over 3. So this is the second method where you change everything in terms of u, including the limits of integration. So either keep the same limits of integration, convert back everything in the original variable and then plug in the limits, or when you do the substitution at that point also change your limits in terms of new variable. Let's try one more example. So we have integral of x square plus 1 over x cube plus 3x square. So the power function, right? So u is equal to x cube plus 3x. So du would be 3x square. Du over dx would be 3x square plus 3. And from here, du is equal to 3x square plus 3 times x, or in other words, you can take 3 as a common factor out. So x square plus 1 dx. And from here, we notice that on the top we have this. So let's just use this value. So from this, we can say that du over 3 is equal to x square plus 1 dx. So plug back everything here. So what we get? So we get integral from, so on the top we get du. In place of this, we get du over 3, and we have u square. And also, I would like to change the limits in this case. Instead of having limits for x, I'll try to have limits for u. So I noticed that when x is equal to 2, so what is my u? So my u function is x cube plus 3x. So u would be 2 cube plus 3 times 2. So 8 plus 6, which is 14. Similarly, when x is equal to 3, so u would be 3 cube plus 3 times 3. So 27 plus 9. So we have 36. So new limits of integration are from 14 to 36. So now our integral becomes 1/3 outside. So integral of u raised to power negative half du, where limits of integration are from 14 to 36. So in the next step, when we take the integral, so we increase the power by 1. So it means u raised to power negative 1 over negative 1, and the limits of integration from 14 to 36. So we get, so negative 1 over 3 you can keep outside. So when you apply the limits of integration, so you have 1 over u from 14 to 36, which in turn you can say that you have 1 over 3, 1 over 36 minus 1 over 14. And when we evaluate this, we get approximately 0.01455 as our answer. I hope that makes sense. So if you like this video, please hit the like button. See you next time.